Well, hello and welcome back to my workbench. It is time once again to try to fix something. And today on the workbench, I'm taking a look at a PS5 motherboard. It was sent in to me. Now, this board comes from a viewer of the channel who goes by the name Dr.Cyrogenic. You may have seen him commenting on some of my videos and other videos, other videos from other content creators, other technicians out there. But that's the name he goes by. And he has sent me, well, several boards, three PS5 boards, I think is a PS4 Pro motherboard, that he asked me to take a look at. And for some reason, I agreed to take a look at them. Maybe had been drinking, I don't know. But here we are. And I have picked out one to take a look at for a video here, at least one. And here it is in front of us. And I'll show you the note he sent along. It's got all kinds of errors. So we're going to be taking a look at this. And I have already looked at the board, glanced at it under the microscope. And I've done no repairs, attempted nothing to it. I did connect 12 volts to it to see how much current it would draw. And I'll show you that also. But basically, it has been worked on. And I'm not sure everything that was done to it. I mean, sometimes you don't know. He's told me what he remembers has been done to this board, but some of it we're just going to have to figure out on our own, I'm afraid. So he did mention this one did not seem to give proper initialization current. So we're going to look at that first thing. I've got my polarity, my leads connected, proper polarity, hopefully. Let's give this thing 12 volts and see what it does. 13, then 29 milliamps, and we sit there. And we sit there. And we sit there. We dropped to 26. I'm going to turn that off. Turn it back on. 29 milliamps. Okay. That's rather dead. So I think he indicated that this one, he did read the errors out of the UART. Which comes out of the South Bridge, but a lot of power fail warnings for the system on chip, the main APU. But I'm not really ready to look at the APU yet because I'm not really getting a good initialization. I'm not seeing it go up to 300 and so milliamps and come back down. So until I see that, I'm not even going to look at the APU and the RAM and that kind of stuff. I want to see it give me what I call a good initialization. So that's what we're starting with. Let's take a look under the microscope. I've already looked around the board and I've seen some things I want to share with you. So let me get set up for that and we'll start looking around the board. All right. I guess we can take the note off for right now. Keep it handy though. And let me see if my microscope is ready to go. As ready as she'll ever be. All right, let's take a little browse around this board. I have already looked around it just to see, anything obvious. And it's had some rough handling, which may have happened in shipping. He had them bundled pretty good, but still. All right, there's liquid metal. Okay, I've seen some of that scattered around the board. We need to clean that up. Oh, right there. That does not look good. That looks like a pretty good short right across our one of our rails into the memory. I'm not sure if that's on the 1.35 or another rail, but yeah, okay, that's got to go. Let's keep looking. More liquid metal there. And I know there's liquid metal. All right, right there's a missing diode. Let me get something to point with. A missing diode right there. Yeah, I'm pretty sure that's what's missing. Now this is behind the connector for your I guess it's NVMe, your expandable storage space. I don't think that would, hurt us at this point. We need to fix that if we ever get it working, but just something to note. It does look like it was knocked off the board. Let me slide this a little closer to me. Let's keep looking. What else we got? Looks like it's gotten hit here, but I don't think that's missing components. I think those are unpopulated. What else? Here's all the area that makes the rails for the APU. The 6-phase and 2-phase. Looking pretty good down there, pretty clean. He did mention in his notes, I believe, that this chip, which is the controller for all those DR-MOS ICs, that has been changed because he was giving an error related to that. So something to keep in mind. It has been changed. And I think, let me raise this up a little so I can tilt the board. Sorry, I'm out of focus for a moment. But I noticed some of these pins may not be quite aligned. Get that right there. I'm not sure if it's in the shot or not. I need to make sure. But, so if we get to that point, we may have to touch some of this up, maybe slide it a little bit, because some of those were a little crooked. And it's easy to do on these style of chips. Kind of like the HDMI encoder IC. All right, let's keep looking though. Stay in focus if I can. Here's our HDMI encoder. Looking pretty good around the HDMI encoder. At least on this side of the board, I don't see anything missing. Keep going. This is the Ethernet connector. That's the back of some of the RAM. South bridge. Now, from what I can tell, the south bridge has not been changed. It looks to be original. I've looked at it. Look underneath it, at the solder balls, and it looks to be factory. So I don't think that's been touched. Our flash memory IC for our firmware has not been touched. Looks like it's factory. Yeah. There's our RT5126 to make our standby voltages. Looking pretty good around there. A little bit of liquid metal right there. Our battery connector has seen better days. What else? We're about made a full circle here. Okay, let's look at the other side of the board maybe. Liquid metal right there. Let's flip it over. That was APU side. This is RAM side. All right, in the area behind the south bridge, I see a capacitor has been knocked off right here. Probably not gonna hurt us though. What else we have? I notice there's a capacitor has been knocked off here. I think this should be the 12 volts coming in for the fan power. Capacitor knocked off right there. Not sure if that's staying in focus. There it is, you can see it. Had some scratches on the board right in here. And this connector has been, this is for the Blu-ray. This is the power connector for the Blu-ray, has been almost ripped off. If you look down in there, you can see I can't get it in focus. I apologize. I'll move the board. You can see how the foil, the copper foil is pulled up. She's been pulled on pretty hard. I think the other side, yeah, the other side's the same way. Yeah, so that's been almost ripped off. But nothing's broken, looks like. Something to keep in mind, though. Let's keep going. See, this looks like, yeah, liquid metal in this area. See right there. And it looks a little bit like liquid metal all around this SSD storage IC. All up through here. Looks like liquid metal. We need to clean that up. And I know I saw, get back in focus here. We've had well, here's a capacitor knocked off the board, looks like. I think that was a capacitor. Make sure it's in the shot. Yeah. I think this has been hit right in this area, but I don't think there was anything mad. I think it was unpopulated. There's another capacitor. That's part of a resistor capacitor network. It's on these. I see it on these MOSFETs a lot. A 1 ohm resistor in series with a capacitor to ground. I don't think that's hurting us right now, but we do need to fix that. Keep that in mind. Knocked off capacitor. What else? What else? I know I saw more. That capacitor's been replaced, looks like. I know I saw some more missing capacitors. Don't recall which part of the board it was. Some flux there. These are USB power switches. A little liquid metal on that, maybe. Yeah. Back to the south bridge. Where were those? Anyway, I think I've seen multiple small missing bypass caps. I don't think it'd be anything fatal. I don't think. But that low current draw, at 29 mils, it sure does sound like a short somewhere. But I wouldn't think it would be in the RAM, although we do have a short on the RAM because we saw the liquid metal. I will go back and get that. Anything right behind the APU? But this is acting like our south bridge is not booting properly for whatever reason. So we're going to focus our attention probably around the south bridge and around the standby power supply for the south bridge. The 3.3, 1.15, there's a 1.8, there's a 1.95, I think it is, coming from over here. So there's lots of little things to check. See if our SSD is getting power, all that kind of stuff. But let me do some cleanup, get rid of some liquid metal that I find, and then we will proceed. Well, I have been looking around in the area of the IC that generates the standby voltages for this board. In this case, the RT5126, and I think I've noticed something. You see something missing? Right over here. That is on pin 10. Goes in it's capacitor from pin 10 to ground. It's a 2.2 mic at, I think, 6.3 volts. And if I'm not mistaken, I have seen one time before on a board I was working on, that capacitor was missing and it would not start up. I think it has to be there. That's what I'm thinking, if my memory is serving me correctly. So I've already, I've looked, I don't have a new one. I do have a donor. So let me see if I can extract that donor. And let's see if that does us any good. I have a feeling it will. Maybe I'm not remembering this right, but I want to say that capacitor has to be there. We need to prep those pads a little, looks like. Looks like that capacitor was knocked off. That'll work. Let me see. All right, we need to see if this has changed our current draw at all. We were drawing just like 29 milliamps. Let's see if I can switch to another camera here. I forgot the best way of showing this stuff. Yeah, maybe you can see there. All right, I'm going to give it 12 volts and see what happens. No, 31 milliamps. No change. I had high hopes for that capacitor. Oh, we keep looking. All right, so we are getting a very low current draw of 29 milliamps and kind of stuck there. Just strange. I have put a scope, get this to focus, on these resistors right here, which are on the data lines between the flash memory IC here and the south bridge, and there's activity there. So it does look like the south bridge is trying to access it and read its, with the contents and read its software. But with that low of current draw, it acts like it doesn't like what it's seeing. So I think my next stop is to go ahead and remove this chip and let's check its contents and see if it looks corrupt. We could substitute another, the contents of another dump that I should have somewhere. But yeah, I think this has not been removed, so it'll be the first time that this chip's been off. But I'm going to remove it. We'll read its contents and see what it looks like. After reading the contents of the flash memory and checking it with the PS5 NOR tool, we have problems. Looks like our Wi-Fi MAC addresses have been wiped out, and we have all kinds of dangers throughout this file. So, yeah, not good. We got a lot of corruption. I may have to see if I can find a donor file to pull stuff from. But yeah, I think that's going to be our biggest issue is corrupt firmware. All right, well, I looked through my files and I did find a PS5 dump for an EDM-031 disc edition, but it didn't say if it was for the 69GG or 61GG, and also it was unknown status. I didn't know if it was good or not. But I have flashed that to the IC. Let's just see if that does anything or nothing. It does, 312 milliamps and come back down. That looks normal, or somewhat normal. Okay. So this board, I think at this point, will try to turn on. It probably won't because of other issues, but I think it'll try. So let me get set up. I probably need to fix some things, like maybe straighten that driver IC for the all those DRMOS ICs over here. This one was a little bit crooked. Maybe I'll straighten that out a little before we try to turn it on. But we're getting closer. Well, I found a chassis, a 1200 series chassis to slide this board into in my parts. Had some trouble finding the right clamp. It has to be a little thin to get past the RAM right there, but I found one. I did notice there's a capacitor busted off right there. So we'll have to remember that. But we're at a point of testing. So let's give it some AC voltage. Yep. And let's just see what happens. What's the worst that can happen, right? Beep on off. That's the worst that could happen. Beep on off. Okay. Okay, we're beep on off. Joy. All right, so we're beep on off now at this point. Let me get this fan out of the way. It was trying to run, but I need to set my meter right there. So what's coming up and what's not? Here's the 1.35 for the RAM. You see it come up momentarily. Okay, I pressed it again to turn it off. There's a couple of 0.85 volt rails over here. Yep, there's another one right there. Yep, all those coming up momentarily. Now we get over here to the what they refer to as the 6-phase and the 2-phase right over here. Nothing. That's the 2-phase. I think this is the 6-phase here. Nothing. Again, not even an attempt to turn on. So we're missing really the main APU rails. These are the high power ones, I imagine, for the graphics, the GPU built in. They should be about 9/10, 1 volt, somewhere in there, and they are not even trying to come on. And that is controlled by that chip that we resoldered. So we may have to look at that area, because there's not even trying to turn them on. The other rails are trying to come up. So, is there something to do with this missing capacitor? I don't know. I'm thinking, trying to remember some stuff in here. I think this may be more related to like the front USB ports. over here. Not 100%, but I'm thinking that's what this was. Some of this is. That's why it's so close physically to the USB ports. So these rails aren't coming up. See if we can figure out why. Do we have a blown fuse? I doubt it's that simple. Like, yeah, I'm sure there's 12 volts right there feeding the rail. So we're just never turning on the transistors, the DR MOS. All right. Well, it's the next day. Let me get you caught up on what I've been doing. Basically doing a lot of comparisons to a similar board here. This is a 30, it's a 31. Yeah, this is a 31 also. So identical board. Didn't really come up with anything though. Nothing solid, just making comparisons. I did go ahead and change out this IC right here. This is the controller IC. Let me get some focus. That controls all these phases going into the APU. I pulled a donor. You know, there's the old one right over there. Pulled a donor off a board that I hope is good. Installed that, see if it make any difference. No difference whatsoever. It had been replaced before, but I wanted to go ahead and do it again just to make sure. No difference. I got to looking real close at what this chip needs to run, and it seems to run off of a 3.3 volt supply. It also gets a 1.8, and the 3.3 I can definitely tell you comes from over here. There's a little 3.3 low dropout regulator there, and this is a 1.8. I think this is the 1.8 that comes over here as well. I need to confirm that though, but I thought it was strange they put it on the opposite side of the board, but that's where it comes from. This pin over here, I believe it was. So it is getting the voltages it needs. Looking at these test pads right here with a scope, I can get that to focus. I see pulses coming out, like it's trying to run. You know, very briefly, not long at all, but it seems like this is doing its job. So then I started looking at the individual ICs, the individual DR MOS ICs, you know, these things right here down through there. What do they need to run? And it looks like they need a 5 volt supply to run. And it is not the 5 volt supply that runs everything else. The one that's, where is it? Right here. This 5 volts that runs, you know, your south bridge. It's not that one. It's a separate 5 volt supply. It's over here. It comes from a little converter right here that takes in 12 volts and gives you 5 volts when it's time to turn on the processor. And I don't think it's working. And let me show you what I mean. See if we can get everything in the shot right here. If I have enough hands, I'm going to give the board focus 12 volts just to let it initialize. Oh, that didn't look right. Now we're hanging. What did I do? Do I have something shorted somewhere? Try that again. The leads are right. Focus. So if I give you 12 volts. Okay, that looked right. Odd. I don't know if I had something touching that shouldn't, but so we're initialized, we're ready to turn on. And I'm going to put this, I'm going to try to have enough hands to do this. Could be interesting. So if I can get my probe on that point right there, let me get this flipped over. I should have just used the overhead camera if I'd realized it was going to be this difficult to do. So I am on that coil for that DC-DC converter, and I am going to try my best to hit the power button and watch this voltage. See it go up to about 0.59 and then bleed back down. That should have gone to 5 volts. It never made it there. So I'm thinking I need to replace this little DC-DC controller. It's 3219 chip right here. I should have some of these. I'm going to swap that out. It doesn't look like it's been swapped out. It hasn't been messed with. So I'm going to try to replace this. See if that gets us back our 5 volts and makes the board a little happier. So let's do that. All right, well, our old DC-DC controller IC has been swapped out. I think I'm ready to give this a test. I don't have a heat sink or anything. I just want to see if I'm going to get 5 volts now. I'll start up normally. That looks pretty good. Or are we going to get 5 volts? If I can do this again. I did it before. Yeah, all right. Should have gotten my meter a little closer. All right, do we get 5 volts? No, we did not. We had something very similar. Let me turn it off and back on. No, no 5 volts. So was it not the controller? Is it one of these MOSFETs? There's not a short on it. I measure like 400, 500 ohms on the output, so it's not shorted, but she's not running. Need to look a little closer at it. Well, we may have done some good. I noticed, and I do have some video recorded of this, I'll try to show you. We replaced this 3219 right here, and it still didn't work. But I noticed on the back side of this chip, on the opposite side of the board, there was a small ceramic capacitor missing. I think I noticed it earlier, I was looking around the board, the first visual inspection, I think I noticed it, didn't think much about it. But there is a capacitor, it's a 1 microfarad, it goes from pin 9 and 10 to ground on this chip, so on the opposite side of the board. I replaced it, pulled one off a donor. And now, if I can show you, if I have enough hands, let's give it the 12 volts. Okay, and we're ready. If I can get on this one more time here to get on the 5 volts and get my other finger here on the power button. 5 volts, and then it shut down. So we did not have that 5 volts before. We have it now. And I didn't notice if my power supply went into current limiting or not. Because that's what should have happened. If those rails started, firing like they should, we should have gone into current limiting, because I've only set for like 2 amps. Let's check it. Let's see if I can do this. I'm going to turn this power off. Back on. All right, you watch over there. Watch the power supply. I'm going to hit the power button. Let's just see if we go into current limiting. Yes, we did. Then we went into current limiting. We went into current limiting. So that may mean these rails are trying to run, the APU rails. Now that they have their 5 volt supply here, they're trying to run. All because of a stinking little 1 microfarad ceramic capacitor. To ground, it was a bypass capacitor, but some of these things are just critical. All right, let me slip this back in the chassis and let's see what it does. I'm excited to find out. Okay, I've got to slip back into the chassis. So at least we'll have a heat sink. I do have a monitor hooked up. I've got the fan hooked up. I've got the ribbon cable for the LEDs hooked up. Let's give it some power. Power supply started. Drum roll, please. She's on. She stayed on. Fan is spinning. Blue light is flashing. I hope to get a picture up there. Nothing yet. We're still flashing. No, we went to white. We went to white. Maybe I don't have my monitor. Do I not have my... I'm using an input on my capture card over there that I haven't used before. So I may not have something set up properly. We've got a white light though. This thing is started up. I didn't even look at the HDMI port. I hope the HDMI port's good. I have a feeling it's something to do with my capture card. Give me a moment. Let me fight with the capture card a second. All right, I gave up on my capture and just went straight to a monitor. We're working. We are working. Okay. Wow. I did not expect it to work that quickly. Well, since the board is all I got, I can't really fully assemble this and show you it working. I don't have the Blu-ray drive, I don't have any of that stuff, but I think we have a working board here. So, yeah, I'm going to end it right here. And what can I say? I got lucky on this one. It came back from the dead, but that's a beautiful sight. Well, I hope you liked that one. I thought it was so interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that next repair. Bye for now.